Hello everyone, today we are going to do a package twister of CCNA 3 version 7, 10.3.4 package twister, configure and verify NTP, addressing table, N1, R1, R2, here's N1, the server, R1, R2, switch. Okay, in this activity, you will configure NTP on R1 and R2 to allow time synchronization. A network time protocol, NTP, synchronizes the time of day among a set of distributed time servers and clients. While there are a number of applications that require synchronized time, this lab will focus on correlating events that are listed in the system log and other time-specific events from multiple network devices. NTP uses the User Datagram Protocol, UDP, as its transport protocol. All NTP communications use Coordinated Universal Time, UTC. An NTP server usually receives its time from an authoritative time source, such as an atomic clock. Attached to a time server, the NTP server then distributes this time across the network. NTP is extremely efficient. No more than 1 packet per minute is necessary to synchronize two devices to within a millisecond of each other. Step 1, NTP server. NTP server. Server N1 is already configured as the NTP server for this topology. Verify its configuration under Services NTP. Here, server N1 services NTP. All right, we look at the NTP is on, so NTP is configured. The time is October 2019. The date is 12. So October 12, 2019, 8 o'clock in the morning, 59 minutes. All right, so let's B is from R1 ping on N1. So from R1 to ping N1 to verify connectivity, the ping should be successful. Repeat on R2. Okay, here, ping from R1 to N1. N1's IP address is here. So ping 209.165.200.225. It shows yes, successful. And the ping from R2 to N1. So ping 209.265.200.225. Yeah, successful as well. So both routers ping are successful. So step 2, configure the NTP clients. Cisco devices can be configured to refer to an NTP server used to synchronize their clocks. It is important to keep time consistent among all devices. Configure R1 and R2 as NTP clients so their clocks are synchronized. Both R1 and R2 will use N1 server as their NTP server. So A, check the current NTP and the clock settings on R1. So it's the show NTP status. Okay, so NTP is not enabled. That means NTP is not configured on R1 yet. And let's check the clock. Show clock detail. All right, so this is R1's time. This is the time, Sunday, February 28th, 1993. Time source is hardware calendar. This is the time, the time information about R1. Okay. So let's configure. B, configure R1 and R2 as NTP clients. Use NTP server command to specify an NTP server. Configure terminal. So NTP server IP address 209.165.200.225. This IP address is the IP address of the server N1. Okay. So now we configured R1 as NTP client. Let's repeat on R2. We still start from checking the status. So show NTP status. Yeah, R2's NTP is not enabled. Enter the clock. Show clock detail. Okay, so here R2's clock. This is the time, Sunday, February 28th, 1993. Time source is hardware calendar. So the information is the same as we see on R1, right? So configure terminal NTP server 209.265.200.225, right? So this IP address is server N1's IP address. So, and so both routers, we configured NTP on it. So let's check. Step 3, verify NTP settings. All right, check the clocks on R1 and R2 again to verify that they are synchronized. R1. Let's check. All right, R1 show clock detail. See, the year changed, so it's synchronized. Before synchronization is Sunday, February 28th, 1993, but now is Saturday, October 12th, 2019. Time source is NTP, so synchronized. Before is hardware calendar. Let's compare the server N1. The information is supposed to be the same. Here the time, NTP on, October 12th, 2019. Here is Saturday. Here's a Saturday, October 12th, 2019. So R1 is synchronized. And we need to check synchronize. And we check the status. Show NTP status. So status shows, okay, clock is synchronized. Yes, so R1 is synchronized. Stratum 2. Stratum is a level. Stratum level is an NTP networks use a hierarchical system of time sources. Each level in this hierarchical system is called a stratum. Stratum level is defined as the number of hop counts from the authoritative time source, and the synchronized time is distributed across the network by using NTP. So now R1 is on the stratum 2. R1 is on stratum 2. Reference is this. This is the server N1. The reference time is the server N1. So server N1 is supposed to be on stratum 1. Yeah, we can see from the association. Show NTP association. Okay, here, association. Here the address. This address is server N1's IP address. So R1 is associated with server N1. This is server N1's stratum. Server N1 is stratum 1. R1 is stratum 2. So this reference clock is supposed to be stratum 0. But here it shows 127.1.1.1. This is the loopback address. That means server N1's reference clock is itself, but it is not. This is just for the packet tracer activity, I think. In the real life, normally, you're supposed to be stratum 0, but it will not show stratum 0. It will show the stratum 0 devices, like a GPS clock or the atomic clock. Because stratum 0 is the most accurate authoritative time source. Stratum device are atomic clock and GPS clocks. Okay, let's check R2. R2 show clock detail. Okay, here. Yeah, here, October 12th, 2019, Saturday. Before is February 20th, 1993. Before is hardware calendar, the time source. Now is NTP. So it's synchronized. So, and show NTP status. Yeah, here shows clock is synchronized. Stratum 2, yeah, same as R1. R1 is stratum 2 as well. Reference is server N1. Server N1 is stratum 1. We can see from association, NTP association. Okay, yeah, this address is the server N1's IP address. This is the server N1's stratum 1. The R2 is stratum 2. Here's still the reference itself. That is, in the real life, is not. There should be GPS or atomic clock. Stratum 0's device. All right, so we finished this packet tracer. Configure and verify NTP. Thank you for watching my video. If you like my video, please thumbs up and subscribe my channel and share with your friends. See you next time.